when you are graphing, the main important thing, Kelsey, that you want to make sure you can at least look at is identify the transformations. All right? And since we have x minus 3, we know that's going to tell us to shift our graph, shift 3 units to the right. OK? So guys, this goes back into a couple different ways. We can do this multiple different ways. And the first thing we're going to do is rewrite the parent graph. Because just like a quadratic, when you guys are graphing a new function, you have to understand what the parent graph is going to look like. And we have the parent graph, remember, crosses at 1, 0, and then has another point at b, 1. All right, whatever the base is. So remember, this is y equals log base b of x. That's what we call the parent graph. All right? So if I was to go ahead and graph this, if I wanted to just graph y equals log base 4 of x, right? If I just wanted to graph log base 4 of x, my graph is still going to have my point 1, 0. And then when I put b in for x, b in for, or my base 4 in for x, so this would be log base 4 of 4, which is what? What is log base 4 of 4? 1, right? So if I put in 4, so it's 1, 2, 3, 4 up 1. So that's what the graph looks like with no transformations. And then all it says is to shift the graph 3 units to the right. So you take these points and go 1, 2, 3. 1, 2, 3. And that's what the graph looks like. All right? Now notice also, remember, there's an asymptote at x equals 0. So if I shift that asymptote 3 units to the right, I have a new asymptote at x equals 0. And then I can simply erase my parent graph. And that's what your graph should look like. There's another way you guys can do this. You guys can also just describe, you guys can also just use a xy table. The same thing. If I have y equals log base 4 of x, just do the parent graph. If you guys just do an xy table, the 2 points that I want you guys to plug in for x would be x would be 1 and b, whatever the base is. Well, in this case, in this problem, my b is 4. So when I put in a 1 and a 4, well, obviously we put 1, we get 0. 4, we get 1. And there's your 2 points. And then you guys just follow the transformations. You graph it, and then you shift it 3 units to the right. Now, if you guys notice, the domain is the set of all x values. The set of all x values do not go do not go to the left of 3, right? So the domain is going to be from all values that are greater than 3. The range, this graph, is going to decrease infinitely and increase infinitely. So that's going to be from negative infinity to infinity. And my asymptote, remember, originally is always at x equals 0. But since my graph shifted 3 units to the right, I can say now my asymptote is at x equals 3. All right? I know I didn't ask that for you guys, but I know some of you guys had trouble with that on your test. So probably well suited.